now that we've looked at databases and we can see how they're structured into tables, and those tables have relationships to each other, let's talk about SQL, which is the language that we use to interact with our database server to actually make our data do something useful, retrieve data, delete data, modify data, whatever, right? So now that we've talked about how the data is stored, let's talk about how to do stuff to the data. So SQL is used for performing what are called CRUD operations. Prior to a few years ago, I had not heard the term CRUD, so I assume it is some hip, new, cool acronym. But there it is. It stands for Create, Retrieve, Update, Delete. Those are the four things that you typically do with your data. And SQL is the language for doing that. So in these examples, let's assume that we have a table called users, and it has the following columns. It's got an ID column, or F first name, last name, and a login. So it's got four columns, four fields, and these are the data types for those particular fields. So ID is an integer, first name, last name are strings, and we've got a timestamp. So let's take a look at what operations we could do to retrieve stuff from our tables. Now, in this set of slides or this presentation, I'm not going to talk about modifying or deleting data. We're just going to be retrieving data because I don't want people deleting stuff out of my database, because then I have to go set it up again, and that's more work, right? And as long as we can select stuff out and perform some operations, you can fill in the blanks yourself and go learn how to do the other types of operations. So the simplest type of query that you can do is a select operation. So find me all of the columns from a particular table. So we could select one column, we could select a few columns, a few specific columns, or we could select all the columns from a table. So let's take a look at that. Select fname from users. This would pull out all of the fname fields from the table. So we would get every fname field in the table. So like Bob, Jane, Joe, whatever. All the first names out of the users table. So this is a totally valid query right here. Select fname from users. Assuming we have a table called users, and that table has a field called fname. What if we wanted to select more than one column out of that table? Well, that's very easy. We just, instead of having one table here, we have or one column name, we have two column names, and we separate them with a comma. So we provide a comma separated list of the columns that we want to pull out of our database. So this would pull all the first name and last names out of the users table. So if you can want to select more than one column, or you want certain specific ones, just provide them, but separate them with a comma. What if you wanted everything out of the table? Select star from users. So the star is a wild card. It just means everything. If you're just looking in the database to see what's in there, select star is fine, but I would never put star in an actual query that you're going to use in, like, in a real production context. I would not do that. I would write out your queries specifically. Now, generally, you do not want everything from your database. Like, that's just kind of like overkill. And really, most of the time when you're looking for something in the database, you're looking for something that matches a certain criteria. Like, find me all the webcams under $50. Find me the closest McDonald's to my zip code, right? I'm not trying to pull out every McDonald's. I'm just trying to find the closest one. I don't want every webcam. I don't want every product in the database. I just want webcams under $50 or less than 100 or whatever. So we need ways to filter those results so that we limit what comes back to what's useful to us. And that's where the where clause comes in. So we can have a select statement followed by a where clause where we provide a condition that says whether a result is selected or not. So here's an example of a where clause. So select first name from users where the last name is Wright. So this would pull out like Elliot Wright, Owen Wright, Evan Wright. So the first part would filter, would get everything out of the database, but then filter it using the last name as the filter. And that way I don't get everything back. I just get back the records where this condition is true, that the last name field for that record happens to be Wright. It doesn't have to be an exact match. I could provide less than, greater than, equal. All the relational database or all the relational operators that we use in programming work in SQL as well. So if assuming I had a table of products for a store or something, and every product has got a name and a cost. This would pull out the name and cost for every product where the cost was less than $100. So pretty easy to understand there. So rather, I don't want everything in the store. I want everything in Micro Center. I just want the ones where the cost is under $100. And just kind of mixing and matching what we've already figured out or what we've already learned. If we use the star pattern, this would pull out all the users where their last name is right. So it would pull out but it would pull out every field. So this would give us first name, last name, social security number, whatever's in our user field, right? Last login, or whatever's in our user table. This is going to give us all the rows for these users where this condition is true. So we won't just get the first name and the last name. We'll get first name, last login time. We'll get the complete record for that, for those, and for anybody in that table whose last name is right. We can have the database server count stuff for us. So find me the number of, or count me up the number of students who still owe money or something like that. Find me the number of products that are over $100. We can have a select count and then give it the field to count up and provide a where clause. I don't use count that much. And an or. So what if we want to make sort of a compound expression in our where clause? So maybe we want all the products between $50 and $100. So if we wanted something like that, okay, find me the name and cost of everything in the products table where the cost, where the value of the cost field is between 50 and less than 100, right? So it's between 50 and 100. So it's actually the word and, it's not the double ampersand, it's not the pipe, right? You can use and or in your where clause to make more complicated where clauses. So, you know, you're not just limited to it's less than this or it's greater than that or it's equal to that, right? You can actually put in here whatever you want. You can make compound expressions using and or. And in any real database situation, you will have lots and lots and lots and lots of records. And sometimes, you know, you just don't need them all. So if you want to limit the amount of data coming back from the server, you can use the word limit. So you can say something like select the name and cost of all the of everything in the products table, limit 10. So that would give me the first 10 things in the product table. So however many million records are after that, I don't see them. I don't care. So limit is useful for just, you know, keeping or restricting, holding down the size of the result set that you get back from the server. And whether, you know, and using limit depends on your context. But you can definitely say I don't want all the records. I just want the first 10. And we can also sort our results that come back using an order by clause. So we could specify a criteria to sort the results on. And we can control whether the data is sorted in ascending order or descending order using ASC and DESC. So we can say sort by something ascending or sort by something descending. So back to our products table here at our imaginary store. Find me the name and cost of all the products, but then sort them by cost descending. So that would put the products in order. It'll give me the name and cost of all the products, with the most expensive one first, going down to the least expensive. And if I wanted it to go the other way, I could put ASC there. And if you put it, if you don't put ASC or DSC, I can't remember whether you get ascending or descending. I think you get ascending, but don't hold me to that. So that would perform a select and then sort them based on the cost field in descending order. You can you can have multiple order by clauses. So imagine that you wanted to find all the the games in your store and then sort them by publisher, and then within the publisher groups sort them by cost. So you can supply more than one column in the order by clause, and then your data will be kind of sorted into chunks, and then each one of those individual chunks will be sorted. So let's take a look at that. So in this context here, we're going to we'll select the name and cost from our products, order them by manufacturer. So it's going to group them into by manufacturer, and then it's going to, within those groups, it's going to sort them by cost in descending order. And then let's say we want to just limit the number of things that comes back to 25, right? So there's our limit. We don't want everything. Just find me all the roll them up by manufacturer, and then within those groups of manufacturers, order them by cost, and then but don't let the total number of records coming back exceed 25. I'm not sure that query really makes sense. I'm not sure the limit 25 really makes sense in that query right there. But the purpose here is that you can specify multiple fields in the order by clause, and you can mix and match all of these things, right? The where clause, the limit clause, the count, right? You can just, these are just tools, and you can kind of mix and match them to do what you need. Now here's kind of the big thing. This is what we're gonna this is very important, because most of the data is broken up into multiple tables, and you're not, when you're trying to retrieve records, you're not just trying to find the data from one table. You're trying to pull out data from multiple tables that are somehow related, and that's what a join allows you to do. So so remember, we talked about foreign keys. A foreign key is a field that is a primary key in another field. It allows you to associate two tables. That's what a join is. A join is that process of taking one record and using one of its fields to go find the corresponding records in another table and kind of merging them together to create a complete record. So let's take a look at our GameStop database. This is what I'm going to be playing with in the next video. I'm at where I'm actually going to go execute some queries. So every software title has a publisher, and every publisher has an ID number. So remember, this was like, if we have a software, we had Assassin's Creed, and its publisher code was 4 or something, or maybe 5 or 4 or whatever, and then we'd say, okay, now go over to the publishers table, find me the record with ID number 4, and that's all the corresponding publisher information for that particular title. When we actually execute this within a query to get the stuff from this table and the stuff from this table and return it as one complete record, that's called a join. So what we're going to do is use the foreign key here to join to the publishers table. So what does a join look like? Well, you have to have a select. So select everything from titles. Back to, we have our titles table. And we want to join on the platforms table. Okay, so I guess we're not going to do the publisher. Let's go back to our schema here. So we have a platform table. So maybe Assassin's Creed has, it runs on platform 3, and platform 3 happens to be the Xbox. That's what we're going for here. So select everything from the titles table and then join on the platforms table. Now, then we have to say what key or what fields in those tables are we matching up. So that's, we're going to say join on the platforms table on the titles.platform equals platforms.id. So let's go, I know that was a lot. Let's go back and take a look at it. So our titles table has a platform field, and that platform field is associated with the ID field in the platforms table. And let's go back to the platforms table there. So we are so the titles platform equals is kind of matched up or associated with the platform's ID. So I hope you see that there. The titles platform corresponds to the platform's ID. If you actually look at it in the schema, it actually makes a lot of sense. And I kind of paused there for a second because I was actually trying to figure out what that query was supposed to do. But now what I realize what it's trying to do is it's selecting everything whose platform is the Xbox, right? So it's going to look at every record here in the titles table, match it up with the corresponding info in the platforms table, and if the name in the platforms table is Xbox, then we get that as the result. So that's going to filter out everything that runs on the X box. Now what about all of the dots right here? What about, why do we have platforms dot, titles dot, platforms dot? Okay, so the thing is, when you have multiple tables in a query, it is possible so that we have the same field name in both tables. So notice that titles has an ID field and platforms has an ID field. So we can't just say ID, because which ID do you mean? Do you mean the one in the titles table, or do you mean the one in the platforms table? So that's why you have to preface or qualify each of the fields with the table that you're referring to. So so we have to say platforms.id here, because we don't want it to accidentally be mistaken for titles.id. And in fact, if there were any ambiguity, the query would not run. So when you do the join, you have to join, well, you have to say what columns you're joining on, and then specify them. And if there's any possibility of a name collision, you have to qualify them with the table name. And then notice we have a where clause here, and we could also put a limit, or we could put an order by, right? So now we can actually write some reasonably complicated queries where we pull in data from multiple different tables and associate those all into one kind of complete record. But there it is. There's a join. So you have the join, and then the table you want to join on, and then an on followed by the two fields that you are associating. And you can also, in this query, we're just joining to one other table, but you could have as many join clauses as you want, right? So let's go back to our schema here. So titles are, we could join to the publisher table, or we could also join to the platform table. So we could have two joins in that query. So where did my I got all out of whack there. So we could have join on the platforms, blah 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 blah, join publishers, blah 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 blah, where, and then have the where clause at the bottom. So you don't just have, you're not limited to one join clause. You could have multiple join clauses in there, and that's it. So now what I'm going to do is in the next video, I'm going to pop over to my web browser, and I'm going to log into my Raspberry Pi, which is running MySQL, and I'm going to run some queries on this database right here, which I have populated with data, and we can actually just watch that and see that run. And then finally, what we'll do is when we get to LINQ, you'll see that LINQ is trying to mimic this structure. It's trying to provide us a mechanism for executing queries and filters like this in a way where the syntax is compatible with C#. So I know this seems like a long-winded detour, but what we're really doing here is getting the context or the understanding for what LINQ actually is and what it's trying to do. All right, so in the next video, I'll see you where I do some demos.